Hello everybody, welcome back to chemistry. We are still talking about acids and bases, and today we're going to be looking at Lewis acid and bases. But before we get started with Lewis, we're going to do a quick review on the other two groups of scientists and how they define acid and bases. First things first, Arrhenius. Arrhenius is the basic definition of acid and bases that we mainly will be using here in chemistry. It's any compound that starts with an H is an acid. Any compound that has a hydroxide in it is a base. And we keep it real simple. An acid is any compound that puts H pluses, the H plus proton, into solution. A base is any substance that will put a hydroxide into solution. Real nice and simple definitions. And we went ahead and talked about acid and base strengths. Remember, strength is how much it dissociates. Does the molecule completely dissociate? That means it's a strong acid. Or does the molecule only partially dissociate because it has the reverse reaction and then it's only a weak acid or base? So those are the two definitions. Remember, concentration is separate from strength and weakness. You can have a concentrated weak acid and you can have a dilute strong acid. So concentration is separate. Then we looked at Brønsted and Lowry. Brønsted and Lowry says an acid is a substance that donates the H plus proton, and a base is a substance that accepts the H plus proton. So with Brønsted and Lowry, we're actually looking at what's happening with the proton. So we're looking at where's the H plus coming from, where's the H plus going. So then we have this reaction here. If we have NH3 plus water, H2O, that's going to give us NH4 plus OH. Okay? So if we're looking at this, who is the acid and who is the base? Okay? Who is the acid and who is the base? So overall, if I'm just looking at this reaction right here, I'm going to tell you that NH3 is a base. Because when I dumped NH3 into water, what was produced? Hydroxide. And according to Arrhenius, anything that puts hydroxides into solution is a base. So I'm calling NH3 a base. But let's see if Brønsted and Lowry agrees. We're going to draw the Lewis dot because it makes it simpler to see. So we have NH3 here. And we have water right here. Draw his two paired unshared. And that's going to give us NH4 plus this hydroxide ion. Okay? Negatively charged, positively charged. So taking a look at this right here. What's happening with the hydrogen? We can see that water right here is going to lose this hydrogen. And who's going to pick up the hydrogen? Boom. The NH3 is going to pick up the hydrogen. And by definition, who donates the hydrogen? Water donates the hydrogen, so that makes water the acid. And then who accepted the hydrogen? Well, NH3 accepted the hydrogen, so that makes this guy the base. So just by looking at who took the hydrogen and who lost the hydrogen, we can automatically determine acid baseness. So taking a look, NH3 is the base because he accepted the hydrogen from water. And according to the definition, whoever accepts the hydrogen is the base. And yes, Brønsted and Lowry agrees with Arrhenius that NH3 is indeed the base. So these two guys, these two groups of scientists are agreeing with one another. I say groups because Brønsted and Lowry is actually two guys here. So Brønsted and Lowry, Arrhenius, agree that NH3 is the base, but they're looking at two different things. So that's how Brønsted and Lowry works. We're looking at what's happening with the hydrogen plus, where's it coming from, and where's it going. Now today we're going to look at Lewis acids and Lewis bases. Lewis is a little different. Lewis looks at what's happening with the electrons. Arrhenius just looks straight up. Who has a hydrogen, who has a hydroxide, and who dumps it in water. Brønsted and Lowry is looking at what's happening with the proton. Where's the proton coming from? Where's the proton going at H+. Lewis is looking at Electrons. What's happening with the electrons? How are these electrons moving around? So here's what Lewis said. Lewis said an acid is an electron pair acceptor, and a base is an electron pair donor. So the base is the guy who's donating electrons, and the acid is the guy who's accepting electrons. So we got to take a look here. What's happening with electrons? We're going to go ahead and use this equation we got right here that we used for Brønsted and Lowry to show, does Lewis agree with Brønsted and Lowry on Arrhenius when we're talking about who's an acid and who's a base? So let's look at electrons here. I'm going to put this electron, that's hydrogen's electron right there. And this electron belongs to oxygen. In this color blue, this is nitrogen's electron and nitrogen's other electron. Now, what's happening with electrons here? We got to track what's happening with electrons. So we're going to look. Here's what happens. Oxygen is going to steal hydrogen's electron. Boom. He's going to go there. And if we look right here, there goes hydrogen's electron. I'm sorry. There goes hydrogen's electron right there. So we know that water accepted hydrogen's electron. Okay? We know that water accepted hydrogen electron. And when hydrogen became this H plus floating around, nitrogen donated the 2 electrons to this hydrogen to make this bond. So these 2 electrons right here actually belong to nitrogen. So to make this bond right here, he donated his 2 electrons. Now, by definition, now that we saw what happened with the electrons, water accepted hydrogen's electron, and nitrogen donated those 2 electrons to the loose hydrogen once it was formed to form the bond here. So here's nitrogen's 2 electrons, here's hydrogen's 1 electron, and we designated he's the guy that donated electrons, he's the guy that accepted. So according to the definition, the guy who accepted is the acid, and the guy who donated is the base. So we can see that all 3 groups of scientists are in agreement of what acids and what bases are. When we look at electrons, tracking electrons, NH3 is a base. When we look at tracking protons, NH3 is a base. When we look at who donates hydroxides into solution, NH3 is a base. So looking at all 3 scientists and knowing what their definitions of acids and bases are helps us really determine who is the acid and who is the base. And guys, we need all 3 because it's not always clear who is the acid and who is the base. It kind of is with Arrhenius, but what if it doesn't start with an H or end with an OH? Then we don't know. Then we have to track hydrogens or we have to track electrons to actually see who that is. But with these simple definitions, guys, we can know every time who the acid and who the base is. This is the Lewis acid and base definition, guys. Electron pair acceptor is the acid. Electron pair donor is the base. I hope this helps. This was a review, and you learned about Lewis Dot. I'm not Lewis Dot. He did create Lewis Dot, but you learned about his definition of acid and bases. And now you have all 3, so you'll always be able to tell. I hope this helps, and have a great day.